Hello and welcome to my channel. In this video we are going to learn how to differentiate the given functions with respect to x using the chain rule. So here we are going to learn how to differentiate these simple functions, and at the end we are going to solve a word problem as well. So let us start with the first one. Differentiate with respect to x. The first one is 2x plus 3 the whole cube. Now when we are differentiating these kind of functions with respect to chain rule, we have to make use of 3 steps. So let us start with step number 1. So the step number 1 is differentiating the outside. Now outside means the entire bracket terms need to be treated as an x term. So for time being, let us consider this as x to the power of 3. Now once we have come to this point, we have to apply the power rule to differentiate it. So here the power rule is d over dx of x to the power of n. So here the power jumps out, so we can see n is over here, and it multiplies with x. Now the power of x reduces by 1, that is n minus 1. I have explained all the formulas of differentiation, that is power rule, chain rule, product rule and quotient rule in this video. So you can check it out by clicking on the link over here. Now coming back to this, now applying the power rule to this bracket, d by dx of 2x plus 3 the whole cube becomes, now you can see the power has jumped out, that is 3 times. Now we are going to write the same bracket term, that is 2x plus 3, and the power of the bracket reduces by 1, that is 3 minus 1. So for this one, the step number 1 is applying the power rule. Now once we have got this, the next step is simplification, that is 3 times 2x plus 3. Now this 3 minus 1 power becomes 2. Now let us move on to the step number 2. So step number 2 is differentiate the inside, which means the terms which are inside the bracket needs to be differentiated now. So d by dx of 2x plus 3 will be equal to, now the differentiation of 2x gives us 2 and the differentiation of the constant gives us 0. So I have not written 0 over here. So the differentiation of 2x plus 3 gives us 2. So step number 1 is done, step number 2 is done. Now let us move on to the final step, which is multiply both the terms that we have got in step number 1 and step number 2. So in step number 1 we have got it as 3 times 2x plus 3 the whole square. Now in step number 2 we have got 2. So we have to just multiply step number 1 and step number 2 terms. Now here 3 times 2 gives us 6. So the differentiation of 2x plus 3 the whole cube becomes 6 times 2x plus 3 the whole square. So we have differentiated this function using chain rule. Now let us move on to the second question. Now the second function is x square minus 7 over x. Now the whole thing is raised to the power of 5. Now we are going to use the same steps. Step number 1 is differentiation of the outside. So here we have written differentiate the outside, that is d by dx of x square minus 7 over x, the whole term raised to the power of 5. Now applying the power rule, we are going to consider this bracket term as an x term. So basically it looks like x to the power of 5. So applying the power rule, the power jumps down, that is 5 times. Now we are going to write the same bracket term, that is x square minus 7 over x. Now the power of the bracket term reduces by 1. So it becomes 5 minus 1. Now simplifying this, we get 5 times x square minus 7 over x, the whole term raised to the power of 4. Now the step number 2 is differentiating the inside. Now here, before we start differentiating the inside term, we need to do a small adjustment. So here, d by dx of x square minus 7 over x, we have to take this x which is in the denominator to the numerator. So here the function becomes d over dx of x square minus 7 times x to the power of negative 1. Now here, since x was in the denominator, the power was positive. Now when you take it to the numerator, the power becomes negative. This is done by using the laws of indices. Now once all the x terms are in the numerator, we will start differentiating them. So to differentiate x square term, we are again going to make use of power rule. So here d by dx of x square becomes 2 times x to the power of 2 minus 1 minus, now again using the power rule for the second term, we are going to write the negative 1 jumps down. So negative 1 times 7 times, now x to the power of negative 1, negative 1. The power reduces by 1. Now simplifying this, we get 2x to the power of 1, minus of minus becomes plus, 7 times x to the power of negative 1 gives us negative 2. Now again writing it into the standard form, it becomes 2x plus 7 times. Now let us send this negative power to the denominator. So it becomes 7 over x to the power of positive 2. Now once we have got step number 1, step number 2, let us proceed to step number 3. So step number 3 is just the multiplication of step number 1 and step number 2 terms. So the differentiation of the entire term given will be equal to step number 1, which we have written over here. 5 times x square minus 7 over x, the whole thing raised to the power of 4, times, now the second step answer, which we got it as 2x plus 7 over x square. So this is the differentiation of the given function. Let us move on to the third one now. Differentiate with respect to x, square root of 3x to the power of 4 minus 2x square plus 5. Now remember, to differentiate the square root, cube root, fourth root or nth root terms, it is always better to convert these roots into fractional powers. Means, remember, the square root can also be written as something raised to the power of 1 over 2. The cube roots can be written as something raised to the power of 1 over 3. Same thing goes with fourth root, fifth root, sixth root and nth root as well. So it could be written as a fractional power, something raised to the power of 1 over n. So in this case, since we have a square root, we can convert the square root as 3x to the power of 4 minus 2x square plus 5 raised to the power of 1 over 2. So we are converting the square root into a fractional power. Now once we have got it into fractional power, let us start with step number 1, that is differentiating the outside term. So here again we are going to consider the entire bracket as x term. So it looks like x to the power of 1 over 2. So here we have written d by dx of the given function is equal to, now applying the power rule, the power comes down, so we can see 1 over 2 times, now the bracket term 3x to the power of 4 minus 2x square plus 5, now the power of this term reduces by 1. So here we get 1 over 2 minus 1. Now simplifying this, we get 1 over 2 times the given function. Now the power becomes 1 over 2 minus 1, giving us minus 1 over 2. Now here, since the power is negative, we are going to write it in the standard format. That is, we are going to get it to the denominator. That is equal to 1 over 2 times, now the given function raised to the power of positive 1 over 2. Now we know that the fractional power is nothing but a square root. So let us write it back in the given format. So here we get the term for step number 1 as 1 over 2 times square root of 3x to the power of 4 minus 2x square plus 5. Now let us move on to step number 2. That is differentiate the inside term now. So we are going to differentiate 3x to the power of 4 minus 2x square plus 5. So here, using again the power rule, I have written it over here for easy reference. We have written d by dx of 3x to the power of 4. Now here 4 jumps down and it multiplies with 3, giving us 4 times 3 as 12. Now x to the power reduces by 1, that is 4 minus 1. Minus, now 2 again jumps down and it multiplies with this 2. So 2 times 2 gives us 4 times x to the power of, now the power reduces by 1, giving us 2 minus 1. And the differentiation of a constant, which is phi in this case, becomes 0. So we have not written any term over here. Now simplifying this, we get 12x to the power of 3 minus 4x to the power of 1. So we have got step number 1, step number 2. Let us proceed to step number 3. So multiplying both the terms, we got in step number 1 and step number 2. So in step number 1, we had got 1 over 2 times square root of 3x to the power of 4 minus 2x square plus 5 times, in step number 2, we had got 12x cube minus 4x. Now in the next step, we have just factored this bracket. That is, we can take 2 as a common factor out. So when we take 2 as a common factor, we get this bracket as 2 times 6x to the power of 3 minus 2x. Now we did this because 2 from the numerator and 2 from the denominator can be divided. So 2 1 times is 2 and 2 1 times is 2. So the final answer is the simplified form, that is d by dx of the given square root term will be equal to 6x cube minus 2x over square root of 3x to the power of 4 minus 2x square plus 5. So this is the answer for the given function. Now let us move on to the fourth question. Differentiate with respect to x the given function y is equal to x plus 5 the whole cube minus 1. Now the entire term is raised to the power of 2. Now you can pause the video and give it a try if you want and see if you get the correct answer over here. So let us begin with step number 1, that is differentiating the outside. So here differentiating the outside means we are going to consider the entire bracket as an x term. So this is x raised to the power of 2. So applying the power rule, we are going to write d by dx of the given function is equal to, now the power comes down, this is the outside power, so the outside power jumps down. There is absolutely no change inside the bracket, so we write it as x plus 5 the whole cube minus 1. Now the power reduces by 1, that is 2 minus 1 gives us 1. So this is step number 1. Let us proceed to step number 2. Now differentiating the inside term, that is we are going to differentiate inside the bracket. So here we are going to consider this first, and again applying the power rule we can consider x plus 5 as x. So it looks like x to the power of 3. So applying the power rule, the power 3 jumps down. So we have written here 3 times x plus 5. Now the power reduces by 1, that is 3 minus 1 times 1. Now I have written times 1 over here because we need to differentiate again the bracket term, that is x plus 5. Differentiation of x is 1 and the differentiation of 5 is 0. I have shown this in question number 1 where we had differentiated 2x plus 3 to the power of 3. So you can refer to that question to easily understand this step. Now simplifying this, we get 3 times x plus 5. Now 3 minus 1 becomes 2. Now the final step, that is multiplying step number 1 and step number 2. So here we have written step number 1 terms times step number 2 terms. Now here 2 times 3 gives us 6 and the bracket terms multiplies with each other. We do not have to expand this, so this becomes our final answer. So using these 3 steps, using the chain rule, we have differentiated the given function. Now let us move on to the 5th question. Y is equal to 2 over 4x square plus 2, the whole term raised to the power of 5. Now let us start with step number 1. So before we begin with the differentiation of the given expression, let us take this denominator for x square plus 2, the whole term raised to 5, to the numerator. So using the laws of indices, we can write d over dx of 2 times. Now the whole bracket comes to the numerator and the positive power becomes negative power. Now this helps us to easily differentiate the term. Now once we have done this, we are going to use the power rule. Now this negative power comes down and it gets multiplied by 2. So 2 times negative 5 times 4x square plus 2. Now the power of this term reduces by 1. So we get here negative 5, negative 1. Now simplifying this, we get 2 times negative 5 as negative 10. And this bracket raised to the power of negative 5 plus negative 1 gives us negative 6. Now let us move on to step number 2, that is differentiating the inside terms. So here d by dx of 4x square plus 2, we are going to take the inside bracket terms. So here d by dx of 4x square becomes 8x, that is by using the power rule. And d by dx of the constant term, that is 2, becomes 0. So the differentiation of the entire bracket term gives us 8x. Now the final step is multiplication of terms got in step 1 and step 2. So here we have written d by dx of y is equal to negative 10 times the bracket to the power of negative 6 times 8x. Now negative 10 multiplies with 8x giving us negative 80x and the bracket stays the same. Now writing it into a standard format, since this power is negative, we are going to turn it into a positive power by sending this bracket to the denominator. So the final answer or chain multiplication of the given expression becomes negative 80x over 4x square plus 2, the whole term raised to the power of 6. Now let us move on to the last question, which is a word example. The curve y is equal to square root of px plus q passes through the point 12, 4 and has gradient 1 over 4 at this point. Find the value of p and the value of q. So let us try to understand this question by drawing a rough graph first. So here it has been given that the function or the curve y is equal to square root of px plus q passes through the point 12, 4. So let us say that this is the curve representing y and it moves in such a way that it crosses through the point 12, 4. So 12 is on the x-axis and 4 is on the y-axis. And it has also been given that it has a gradient, that is the slope, 1 over 4. So at this point, if you're going to measure the gradient, the slope, you're going to get it as 1 over 4. Now here we need to find out what is the value of P and the value of Q. So step number 1 would be to get an expression for the curve when it passes through the point 12, 4. So here we have written at the point 12, 4, this is the expression for the curve. Now in place of y, we are going to replace its value, that is 4, is equal to square root of, now x becomes 12, so the expression changes to square root of 12p plus q, that is at point 12, 4. Now let us consider this as equation 1. Now in the next step, let us write the square root in terms of fractional power. So here we are going to write y is equal to, now the square root becomes the fractional power as 1 over 2. So the square root of px plus q becomes px plus q raised to the power of 1 over 2. Now remember that whenever they mention the gradient or the slope represents dy by dx. That is the differentiation of the curve y with respect to x. So here dy by dx is given as 1 over 4. So this gives us a hint that we need to differentiate y with respect to x. So let us start with step number 1, and here we need to use the chain differentiation method. So if you want, you can pause the video over here and give it a try to differentiate y with respect to x. So let us start with step number 1, that is differentiating the outside. So here d by dx of px plus q to the power of 1 over 2. Now using the power rule, we are going to take the power down, that is 1 over 2 comes out, and px plus q, the power reduces by 1, so we get 1 over 2 minus 1. Now simplifying this, we get 1 over 2 times px plus q. Now 1 over 2 minus 1 gives us minus 1 over 2. Now since this is a negative power, let us take it to the denominator. So we get here 1 over 2 times in the denominator. Now we get px plus q. Now the power changes to positive power, that is positive 1 over 2. Now we know that 1 over 2 represents the square root. So we are going to get it back into the original format. That was 1 over 2 times square root of px plus q. Now once we have got this, let us proceed to step number 2, that is differentiating the inside terms. So here differentiating the inside terms, we get d by dx of px plus q. Now d by dx of px gives us p, and d by dx of constant, which is q over here, becomes 0. So d by dx of the bracket gives us p. Now step number 3 is multiplication of step number 1 and step number 2 terms. So here we have written d by dx of y is equal to 1 over 2 times square root of px plus q times p. Now this represents dy by dx, and we had the value of dy by dx given to us, that is 1 over 4. So in the next step, we are just going to take this expression which we got just now as dy by dx and equate it equal to 1 over 4. Now in the next step, we are going to do a small cross multiplication. That is, we are going to take 4 on the other side of equal to sign so that it multiplies with p. So I have written it over here. So 4 multiplies with p, and let us keep the 2 in the denominator, and at the same time we are going to take this square root term on the right hand side so that it multiplies with 1. So here the equation becomes 4p over 2 is equal to square root of px plus q. Now here 2 divides 4, that is 2 1 times is 2 and 2 2 times is 4. So our equation reduces as 2p is equal to square root of px plus q. Now let us consider the given point, that is at 12, 4. We get the expression as 2p is equal to, now in place of x we are going to replace 12, giving us square root of 12p plus q. Now let us consider this as equation 2. So now we have equation 1 with us and equation 2 with us. That was equation 1 was 4 is equal to square root of 12p plus q, and this is equation 2. Now if you compare equation 1 and equation 2, the right hand side terms are absolutely same. So we can equate the left hand side terms, giving us 2p is equal to 4. Now 2 goes on the other side and divides 4, giving us the value of p as 2. That is 4 divided by 2 gives us 2. So now we have got the value of p. But we need to find out the value of q as well. So you can take either equation 1 or equation 2 and plug in the value of p to get the value of q. I am going to consider the equation 1. So here let us write, consider equation 1, which was 4 is equal to square root of 12p plus q. Now let us take square root on the other side of equal to sign. So it becomes square. So we get 4 square is equal to 12p plus q. Now let us simplify this. That is 12p plus q is equal to 4 square gives us 16. Now in the next step we have plugged in the value of p. That is 12 times 2 plus q is equal to 16. Now 12 times 2 gives us 24 plus q is equal to 16. Now taking 24 on the other side of equal to sign, we get q is equal to 16 minus 24, giving us finally the value of q as negative 8. So here we have the value of p as 2 and the value of q as negative 8. So this is the application of chain rule and power rule in word examples. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.